So this example here, question 23, again, we want to factor the polynomial completely. Again, if the polynomial can't be factored, we're supposed to say it's prime. But we haven't really came across one that's prime just yet, so we're going to go in thinking it's going to be factorable. So again, in factoring, notice how the first thing we always want to look for is the greatest common factor. Well, notice how this 3 is a factor of a 6 and a 9. So that means I can actually divide that out or factor it out, if you will. So the first step is actually pull out that GCF of the 3. So when I divide the 3, again, you're going to be dividing each one of those terms by 3. That's how you're just trying to find the remaining factor. So notice how when you factor out the 3's, that's going to leave you this x squared. Notice how 3 times x squared is 3x squared. So we're now writing it in a multiplication form. And when I do a 3 into -6, that's going to give me a -2x. Then when I do a 3 into -9, that's going to give me a -3 there. So from there, notice how again, it's factored, but they want to factor it completely. So the question is this remaining second degree trinomial, is it still factorable? Notice how again, it's not a difference of squares, it's not a perfect square, but notice how it is a second degree trinomial where the coefficient of x squared is 1. So we kind of pick up on that this is going to be 3, and then all I got to do really is set up a set of parentheses. The factors of x squared, there's only one possibility, x times x. So really all we have left to do is what are the factors of a -3 that add up to a -2? Well, the only factors of 3 would be 1 times 3. So 1 times 3 is not -3 though. One of them's got to be negative. But remember, when you have to add them together, you have to get this -2. So it looks like this 3 has got to be negative. So 1 times -3 is -3, and 1 plus -3 is a -2. So that completes the last piece of the puzzle. There's not any other options. So we have to have a +1 here and a -3 here, and that would be the complete factorization of that trinomial.